Okay, in the continuation of our tutorial for Matlab on creating scripts, let us first discuss what I haven't touched yet, which is return arguments in Matlab. So you could actually run a script, then it gives you a return value that you could actually use within the command window. So we need to go on returning arguments. So how do we try to create a function that returns an argument or returns a value to the command window and actually put it on what we call the workspace? So I'll be creating a new script. From there, I'll be having a function again. From the function, I'll be creating a variable. Let's say, for example, variable x is equal to my sum. Then I'll have a comma b. It means that in this particular function, it will take or it will get two arguments or two values, a and b, and from this argument or this values you will try to create a function or an operation here inside the function and pass it through x. So how do we try to do that? So we have a and b here. So from my function, my sum, it means it will get the sum of two values. So I'll have x is equal to a plus b. That's it. You will add the two values coming from the argument and pass it through x and actually put it on the workspace. So I try to click on save here. So save my sum. So I would not run this is because it will ask for us for a argument a and b. So I'll be working on with my command window and type here my sum. Let's say for example 2 and 3. The answer must be equal to 5. So as you can see, it gives you the answer 5 here, and at the same time it goes to the workspace 5. So you could actually use that value in order for you to actually use it on other functions or other commands, or actually pass it to a particular variable. So let's say for example y is equal to my sum 3 and 4. So the value of y now becomes 7. It's because from the function my sum, it returns a value and pass it through 7. Can I have multiple return values? You could do that in Matlab. So again, I go to my editor. I go to new script. So I'll have my function. Let's say for example, let's say I need two arguments, sum and average, and it is equal to sum average, then let's say for example x. The same program that we did on the previous, I'll be creating or I'll be copying the function that we have created on our previous tutorial and pass it on through here and get the value of the sum and the average. So I'll just open. So how do we try to open a function? So you will have your current folder here. I'll be having my average function or my average script in my, let's see if it tries to open. Not yet. I'll try to open it here. It's better I think to open here. So my average, I'll try to copy this, then paste it here. I'll try to change this one. I'll be removing the display here and I'll be changing the average underscore to a big letter A. It's because it will get or it will return, as you can see it's highlighted now, is because it says here that it will return it to a particular function, or it will return on the on a function. So what it does here is it gives the sum and the average and pass it on, let's say for example, to a workspace. So let us try to do this one. So I'll save it, sum average. The next thing that I'll be doing is I'll be using my sum average function. Then let's say for example 3. It gets the sum of 3 values and the average as well. So I'll try to enter, let's say for example 10, 20 and 30. The sum of this one must be 60, and the average, as you can see on the workspace, is 7, but it is not shown here. If you want to show here the value for both the sum and the average, we need to do a matrix, a row vector, so that we could get the value for both the sum and average. So I'll use the variable sum and average here, or you may try to use any variable. Then sum average, again I'll try to use again 3 here, then enter values 10, 20 and 30. When I try to enter, as you can see, you have already 2 values, which is sum and average. If I try to type on sum, you get the value of 60. If I try to get the value of average, so it's individual already. Average, sum, or the average is, why is it it's 20? Average of 3, so 10 and 60, yes, 20. So that's the value for the average. I think this one is fine. So that's it. And how do we try to get or return arguments in a particular function? Oh, the y here is from the previous function. Sorry for that. The y is coming from the previous function. The answer is just it displays only 60 here. So the average is 20. So now for this time, let us try to discuss how do we try to use a while loop. So in programming, while loop is done when you have a particular argument in the while loop, and as long as the while loop is its statement is true, it will run the whole loop itself and returns back and tries to check if the condition is still met. If it is false already, then the loop will stop. Now the application for this one is we could relate this one on using what we call incremental search. An incremental search in a mathematical system, or in a mathematical theories, is that, or a mathematical methodology, is that when you try to work on solving for a particular root in a function, or let's say for example you want to make the function equal to 0, which is actually the root, you are trying to do increments of values of x to make the y either equal to 0 or nearest to 0. It depends on how you try to evaluate your incremental search. So in our function, let's say for example we try to create a function of x cubed minus 0.3. So let us try to do that. So we have, let's say for example x is equal to 0 colon 0.01 colon up to 1, let's say for example, I will have these values so that I could have my y is equal to x, small x, cube minus 0.3. I think we'll have an error here. It's because, as you can see, it needs a dot operator when you try to have a series of values in a particular variable and you pass it on to another variable. So you need to put a dot operator after the current so that it would give us the value. As you can see, there's no value that is being displayed. This is because, again, based on our first tutorial, it is being suppressed by a semicolon. So I tried to plot the values so that we could get what would be the nearest value that would make my y equal to 0. So this would be x comma y. So it will display a particular function, and this shows the graph. To better have a view of the graph, can we have a grid here? Oh, you may try to have some inserts, or I'll try to put or try to type the command grid, and let us see if there would be some grids in our plot here. So we could see here, then where your y is equal to 0, it is near between 0.6 and 0.7. So I zoom this particular area so that we could have an idea as we try to take a closer look on this. So it is within 0.66 up to 0.68. So the graphical method gives us the idea of where does the value of x make our y equal to 0. But we cannot zoom it forever. It's because it's very difficult for us. It's because we need to do this zooming most of the time. Now, what would be the best way for us to get the approximate value of x to make my y equal to 0 or near to 0? So one of the not the best, but the basic methodologies that we could actually do is what we call incremental search, and that is what we will be doing for the demonstration of the while loop. So how do we try to do the method of incremental search? So to do that, so let us try to go to our editor again, create a new script. Now I'll be having a function. This function, my incremental. Well, I'll be having a incremental search. Then I'll have my starting value for x. That would be my idea here. I want to have my function accepts a value of x, where your x is a what do you mean? The starting value on which you try to increment that value of x closer for getting my y equal to 0. Then comma, I'll be having my delta, or the delta means it's delta x. It means that it will give me a certain additional increment, because we call it as incremental search. We increment the initial value of x every time to make it nearer to 0. That's the idea or the ideal concept. So I have two arguments here, the first value of x and delta. Now the next thing that I'll be doing is that I'll be creating a let us try to do a while loop. Let us see on how do we try to progress and improve the program. So while y is not equal, the not equal in Matlab is a tiled sign that is located at the almost the leftmost portion. It's below the escape button. The tiled key then equals, it means that it is not equal to 0. Or I'll put an or here, it's because of the concept. So the or is what you call I call this one is pipeline, double pipeline. It is located below the backspace and it is being shifted. So I call this as double pipeline. While y is not equal to 0, or my increment is not equal to 100. So I need to have some values of y here. Let's say for example I put my y first is equal to 1, so that I still have a value, and run my incremental search after the while loop. Then my increment also is equal to 1. I'll start my increment to 1. I'll make this one less than or equal to 100. Now I put an end here already so that I could have my while loop run for this particular equation, or for this particular loop. So I'll have my y is equal to x cube minus 0.3. That's the idea. We'll try to do the increments, or it's not yet the increments, but rather it will do the operation already, or the function already, and evaluate with respect to y. Now the next thing that we will be asking is if y is equal to 0, then I'll have my end here, and else. If y is equal to 0, then I'll display the value or the root is equal to, so we need to have the value of the particular function. So the root is equal to, I'll be putting also again another display so that I could display x. If not, x will be equal to x plus delta. What does it mean? It means that I will be incrementing my x, and at the same time my I is equal to I plus 1, so that I could have a tracking of my increment. So at the end of the while loop, if it finished up to 100 iterations, then it only goes to show that it doesn't get, it's either it gets the root at 100 iterations, or it finished the iterations for, oh, sorry, it's not I, but increment. I'll be putting this one as increment and increment. Increment. So it means that after the 100 iterations, the final value of x is this. So that would be the case after my while loop. So display if it will not reach to 0. So display, so I'll be having this. Display is, so increment, sorry, after so I'll be putting this one, comma, oops, I'll be having this str cap, again concatenate, after, let's say for example I have int to str so this is increment, the value of x is equal to, so I'll be putting again another comma here, no need, then display x. So that would be our incremental search. So let us try to work with this and see what happens to the program. So I'll try to save this. Save. So I'll be having, so again my function will be y is equal to x cubed minus 0.3 incremental search, open parentheses. So based on our plot here, it is near to what? So it will be, I'll start from 0.669. So that would be my 0.669. Then I'll be incrementing it by a delta of 0.001. Let us see. So 0.669 with a delta of 0.001. Oh, what happens? So it tries to increment first and tries to get, I hope that it will get up to 100. Increment. So it's an OR condition. So it doesn't stop here. So it means that there is a problem in my program because it tries to still run in an infinite amount of time. So I'll be using control break so that I could stop my work and try to take a look on where the line in my program which it actually runs. So it is in line number 6. So if y is equal to 0, oh, it means I think it runs on this particular system, but the problem is it doesn't stop. Okay, as I could see here, if I'll be using, I think the problem in this particular program is this: if I try to use the OR function, even either of the two will return a false, because I want to have what? Either y is equal to 0, or the increment would be at its 100 iteration. So I think I need to put the OR, but instead of OR, it must be AND, because I tried to put a not here and a less than symbol here. So even if one of this will become false, it's because this is OR. Again, on the logical containment of OR, 1 OR 0 is still 1. So it will remain true unless the two conditions are met. It's either that it is equal to 0, that will make this one false, or this would be and the increment must be not equal already to 100. So instead of the OR, I'll be using an AND function, and it is in the terms of ampersand. So that is the end. So it means that either of the two will make this false, then the loop will stop. It must stop at that point. So I'll save the work. So let's see what happens to the program. I'll go back again. So clear screen, CLC, then clear. So I'll have my incremental search. So, I have my increment is equal to 1. It's because I didn't suppress my value here. So suppressing it by using semicolon save. So after the 101, so it means that I missed the iterations. It's because it is equal to 100. So I need to change my program there and make this 100. So the value of x is equal to 0.7690, which is in our graph. It is, I think it will pass the 0 mark. It's because this one is already away from 0 point something here. Now, to refine our function, to refine this, we need to add more on our delta, and again, if we add more delta, we need to also increase our increment. So we need to improve our program here, but instead of less than or equal to 100, I'll make this one less than 100. So it still passed the 100, but not past 101. And at the same time, I'll make this increment, let's say for example higher. Let us see what happens. What I'll be doing in my function now is I try to increase the value of delta. Let us see if I'm correct in here. 0.669 is still here. 0.669 is still here. So it will pass. I hope that it will pass to here. But again, it depends if it will be equal to 0. And I'll be having my delta to 0. Let's make it the delta smaller this time. I hope that it could actually reach the needed. Well, after the 500th values, it's 0.6740. So it's more on a miss shot in this particular. It's because we have a difficulty of reaching this one. It's because of its accuracy. and it missed already because it is 0.7674. So what could be the other way for us to actually make this one near to the value, which is at this point must be equal to 0? The idea here is we could actually use the approximation error to the percent approximation error to have it, we call it as, we try to make this one as the judgment for the getting the value near to 0. It's because it tries to check for the, if the value of x is or the value of y is near already to the exact value, or the value of x is not really changing with respect to the closest of the values. So we could try to do that, so that we could try to further refine the function for the system that we have. So the value of EA, we will be changing the increment. We could do the incremental search, but instead of having this as our increment, or I mean not increment, but rather a judging value, I put this one as EA is greater than 0.005. It means that at 0.5% of approximation error, if it doesn't reach the approximation error of 0.5%, then the system will continue. So we could do this one. So I'll be putting this one as EA is equal to, at first 1. It's just an initialization. So the next idea here is that we need to have value for EA. So I need to have my answer of y previous. I'll put this one is equal to 0, so that I could have my basis of getting for the percent EA. The percent EA is actually the absolute value of the present value of y minus the previous value of y over the previous value of y times, oh well, no 100%. It's because I put this one as in terms of non-percentage, so that would be the case. So EA is equal to y, that is the present value of y, minus y previous. So I'll put this one as in parentheses, so that this would be, so y present minus y previous. I think it's y present. I tried to check. So this would be correct if we try to get the approximation error of the output value. But if you want to get for the so I'll be putting this one as absolute value. This is absolute value. So I'll have the function or the command amps for this particular function. So to get the absolute value for this, it must be an absolute value. Now this would be an output, but sometimes we could use, or most of the time we actually use the value of x for this. So let us see if what would be the case, or what would be the I would say a good interpretation for this, or what would be the good value for this when you try to do incremental search. So I'll try to save this one. So I'll try to have this EA, so that we have the, but we need actually to have also that if else we need to have our y previous now is equal to the present value of y. It's because we need for the next iteration your previous y will be the recent y that you have created, so that's why we have this. So I'll save this one. Now when I try to do incremental search, I hope that it would do a good thing. Oh, I didn't put the I didn't put the value, or didn't put the suppression, which is a semicolon on my EA. So here. So the value after 246 iteration is 0.6714. If we try to do here, 0.6714 is actually here already, which is already positive 2. So it is a hit and miss when it comes to incremental search. Let us try to put, if we have it, instead of y previous is x previous, so that we could have a good interpretation for this. So this would be x previous is equal to x. I'll save this one. So I try to change it if it will be the x value that we will be checking, if it will be less than or equal to 0.05. So I'll save my work, CLC, let us see. So after the third iteration, it's a good value. It's a good iteration. So because it reached on the third value, it reaches on 0.6690. It doesn't reach the actual value for this. It's because it is being suppressed. So this would be 0.00. It has a value over here. So let us see how do we try to make this one longer for the values. So to actually make it or display long values, we could try to have our format for the program. So I'll try to type format then long, so that it would have a longer display of values for this one. I try to save, then try to do again an incremental search. So again, after the third value, this would be displayed. So it means that it gives you a better displays because it adds only from 2 iterations, or on the third iteration where our value is incremented twice. So it gives us this value 0.66902, 0.066902 with possibilities in this position. Let us see if we could try to do this. So we could try to actually, as we try to zoom, we could try to actually do some mitigation. So 0.6694, and let us see if it will reach the near value of this. It's because we try to actually do some mitigations on this. So we could have this one 0.6694. We could start at that. So that is the difficulty of what we call incremental search. Well, I'll put this one to 0.69. Oops. So this one is 0. So we could put it as 0.6693. And let us see if there would be some good changes. So it's still on the third iteration. So it means that it gives us a I good iterations, but let us refine more on the approximation error so that it could give us a precise value for this. So incremental search still gives us on the second value, third value. As we try to increase the number of zeros here, it tries to also gives us a good amount of significant figures. So let us see if we could try to increase it more. It's still on the third iteration. So it means that we have a good value for our iteration. Yes, I think it's near already. 0.6693. We started here, so it means that at that point it is reached zero marking, for this one. It's around 0.6694. So as we try to limit this one, I'll try to reduce the number of zeros here. Let us see if there would be some changes in our, and play around with it. And that's the difficulty of using incremental search. Just like here, it goes farther away, and we all know that it reaches zero at this point. So that is the difficulty of using incremental search. It's because it doesn't give you the amount of value that is needed for you to actually reach to the zero mark. We cannot also put this one, the difficulty of also of using incremental search in this particular system, that makes, let's say, while y is less than 0, we cannot put that one as less than 0 or less than 0.001. It's because if you try to reach negative values, it will go on to stop the system. It's because it's negative. Even it's -1 or -2 or -0.5, it will stop there. It's because it is less than 0. So as you play with the values here, you try to improve your work, or you try to improve the system by either having this approximation error, or well, we could say that we could use the evaluating the y values if it is near to 0, and the percent of that is equal to a certain value. So we could do that as well. So it's up to you, and how would you try to do the incremental search based on what we call the judging criteria, other than the making your function of x or y is equal to 0. So those are the things that you need to consider. But again, this discusses the looping for the while loop, and inside the while loop we try to also put some if conditions so that we could really see what would be the, if it actually reaches 0, then what is the root of the function. If not, what would be the conditions, or where would the increment stop. Right now we try to stop at the third iteration, but again, the answer is a little bit far off with the plot. So that's the difficulty of using incremental search. But there are other methodologies that you could do to find for the roots. But this is what we call a brute force method, and we cannot control the situation for the incremental search. It's because of the conditions, such as what we see right now or what we observe right now. But the program works. The program works in the intent of having the while loop and the increments, finding for the increments. And as we try to do some changes in the, or I would say fine tuning, we are actually having some discussions on the uh, bad side of using incremental search. But nonetheless, it's a fun learning experience of using while loop in this particular tutorial. So again, I'll stop this one for now. Probably I'll be discussing more about the methodologies of or refining this finding of roots by using, let's say for example, bisection method on our next discussion. And for the next series, we will be also tackling up with what we call guide, which is the graphical user interface programming with Matlab, so that we could create a much good programs in a form of user interface. So that will be all for now. I hope that you learned from this one, and I see you guys next time.